All right, here we go. We're back. So today's talk is on context matters. Lachlan already gave you an overview of what AI coding is. I won't hold it against him that augment was not on his slide. I'll bribe him later to get it on the next round. But this space is moving super fast. So I submitted this talk, I don't know, 6 months ago, 4 months ago, and it's basically not useful anymore. Really, the title of this talk should be "You're a CTO, Vibes Won't Cut It," because it's all about vibe coding today. Everyone familiar with the term vibe coding? Some. I'm gonna do some reverse polling here in a second. But it is really great to see a bunch of faces caring about being a CTO. I'm a former CTO, engineer. I've done basically everything in the stack at this point in time. I also don't work at Squared Up, but you can get your own minifig, I think. They have at their booth. So go get yourself a Lego minifig, but I don't work there. It's just a weird coincidence. But I also am the bearer of bad news. So this time next year, half of us aren't going to be here. You can size down the conference. We're all going to be out of jobs. At least that's what people would make you believe. So everybody raise your hand. Oh, wait, hold on. Let me go back. Why are my slides? There we go. Everyone raise your hand. All hands up. All hands up. There you go. Reverse polling. Now, if this doesn't feel like your organization, that in 6 months, 12 months, you're going to be writing code at 30, 60, 90%, put your hand down. If you don't think you're going to be like this in 6 months, it's okay. No shame. Very few, right? Like, I think in the end, we have very few people that think they're going to write code or not write code in a few months. I think there's a couple reasons for that. One, they can achieve those goals because they have massive code bases that have been in existence for 15 years with pretty much every piece of scaffolding, decision, architectural choice you can possibly make has already been made for some of those code bases. If you've ever heard anyone talk about working at Facebook, Meta, they'll talk about like, yeah, I'm working on a button that does a thing in the ads platform for 6 months. Like, there's not a lot that AI can't write when there's that many constraints put around it. So I think you can get that kind of performance that 30% of code can be written in that amount of time. But most of our code bases don't exist that way. I don't think, at least none of the code bases I've ever worked on over my career have ever had that sort of stability and don't need that much transformation. And so I think we're probably still going to be writing code in a few months. Next is AI is actually just writing code. It's still code that's being output. You're still getting JavaScript that still gets compiled, that still gets executed. And complex systems fail. And so who's going to think about those complex systems and think about the problems that come up and resolve those issues? So I still think we have that to go for us. And then lastly, history repeats itself. This is not the first time there's been a lot of like, oh no, there's software engineering is dying. There's nothing left for you to do. We've had no-code platforms before. We've had, some people love the tractor analogy, that tractors killed the farms. Probably not very good economic study because farms produce 60% more food than they used to. Sure, farm workers moved over to like cities, but that also inspired a whole set of industrialization that wouldn't have been possible. So, maybe not the best example of like invention. And the more recent one is the cloud transformation. Anyone old enough to remember like when cloud didn't exist and we actually racked servers and we had sysadmins that were doing that work? Well, all of those people now are getting paid more, doing higher abstracted work, doing more important work. We have more distributed systems. So we didn't just like, oh, sorry, sysadmin, you're not needed here anymore. Like, we put them into work in much more useful categories. So there's lots of reasons to believe we will still be writing code. But the vibes are what's, how code is written today. And if you're not familiar with the term, vibe coding is basically just accepting prompting the AI to generate code for you, making sure it works the way you want it to work, not looking at the code, not caring about it, and just clicking accept until it does what you want it to do, reprompt, accept, reprompt, accept. Now, that's not what we're talking about here, because I'm talking about code that you actually need to put into production, code where you have customers that are using it, security requirements that are using it, compliance issues. You have 4 nines. Do you even know what 4 nines even means? So there's lots of hype around vibe coding. I'm not saying it's not great that our industry is expanding and allowing a lot more people to build software that have never been able to build software before, but I wouldn't say vibe coding is going to kill our industry. So, a lot of technical difficulties for me. So how do we get AI code into production? What does that really mean? What are we talking about there? So I think it's important to step back and be like, well, first, when we worry about getting code into production, what is the job of a software engineer? Would a software engineer that was doing punch cards in the 60s be conceived of a software engineer today? Yeah, they were doing software engineering. That was real software that was running on servers, but we input it in a weird way. Like, what would be foreign to us today? Punching cards would be like, that's software engineering? It was. So really, what's the difference between that and maybe having AI write your software? Is that really that different? As long as the output is what you want it to be. So it's like if you imagine the world of an architect, familiar with architects, and you got blueprints for your house, is the blueprint the job of the architect? Or is the blueprint just an artifact of that? Of all the thoughts, ideas, conception, that's just an artifact. A blueprint is just the residual of need that you have. Code is no different from us. I don't think code is any different is just like a thing I produce because I need to in order to get my business cases done, in order to get the features I need built, to get the performance I need, whatever those things are. But the problem with thinking about code in this way is that it's not just an artifact, is that code actually has some unique characteristics that are challenging. Jeff Atwood of Stack Overflow fame, rest in peace, Stack Overflow, said that the best code is no code at all. Why? Because every line of code that you write has to debug, has to be maintained, has to be upgraded. It's a liability. It's not an asset that you have. Every line of code that you produce, you don't necessarily want to have. And if you can make it that way, that's great. And every line of code has trade-offs built into it. There are 50 ways to do anything in any programming language. Which way you constrains you in certain ways, creates opportunities in certain ways. Now you think about all the different ways you can do that in different programming languages, and you've got this explosion of ways to solve the same problem, but all of those come with some kind of trade-off, right? Like, if I'm doing it in JavaScript, it allows me to do this. If I do it in Go, it allows me to do that. I think there's no better way to see that than in architectural choices. In a monolith, in a microservices architecture, or an event-driven architecture, all of those have choices that we've made as engineers built into them. Code runs on them. Code can be very similar on them. But all the choices I make change what I can and can't do and what the software has to do. When you think about AI writing your code, AI doesn't understand architectural choices. They don't understand trade-offs. It's a code generation system. It's a text generation platform. It doesn't have an understanding of why I'm using Kafka to solve this problem, or why my monolith is not performing because I've got some wrong abstraction on it. And to know that's the solution, that's the software engineer's job. That's not writing code. That's understanding the trade-offs you have to make to fix those problems over time. And software is like a cobweb, right? If you pull on one string, the whole thing's going to move with you, and it has to adjust in order for it not to fall apart. And I think our code bases are exactly the same way, and AI has a tendency to work in a very local fashion. Great, I can see this file. I can see these files. But again, all of these trade-offs are tied together in a unique way that make them custom. So for me, software engineering is not about writing code. It's really about how do I change my software, because I have to evolve my software. I'm assuming that's what we're all doing over time. And even adding new features is just changing software. But more importantly, I have to do it safely. That's, for someone that's run production systems, that is the end-all, be-all. Is this going to serve the traffic I need? Is it going to do the thing it needs to do and to do it without errors? And we've been building in safety systems into our code bases for a long time. We have version control for rollbacks. We've got testing right? Like we write tests, so make sure that when I make a change over here, I don't break something over there. We've got type systems for those kinds of things, so I don't end up passing around data I don't expect. Red-green or blue-green strategies, canary deploys, all of those are safety systems we built into our software. Can AI be another one of those safety layers, right? With the right AI that has, the thing that I love about AI is like has a window into the entire system, and it knows things that maybe didn't exist. Anyone ever written like a function in their code base that then like 6 months later, someone's like, you know, we already do that over here, right? Anyone? Is that just me? It's okay. So AI would know that, right? Like as I'm writing this code, as I'm asking questions through a chat interface, for example, it can point me to like, oh, that problem's already been solved. It's solved over there, so use that function instead rather than bringing in a new package. So can AI end up being one of those ways that we can improve the safety of our systems and the safe deployment of our systems? I want to think about AI in that way, more than I want to think about it as generating code. But like it or not, AI is writing code. It's just where we're at, and I don't think there's anything wrong with that. I think, I don't think it makes an author any worse of an author if they have an editor that improved the article. What's the difference between me being the editor for the code and the AI being the writer? It's a great piece of writing, no matter where the source of it came from. So let's say that AI is going to write our software. That's the future. But I haven't seen the adoption of AI in, I'll call it professional engineering practices, that I have seen in other technical things I've done in my career. I was an early employee at New Relic. I was an early employee at GitHub. Like, I've seen transformations in organizations a lot. Why is it that engineers are having a hard time adopting AI? What makes them uncomfortable about it? Some, not invented here syndrome, right? Like, just, I like to write the code, I write the code, it's the right code. There's a bias for perfection, right? We like to think, this is the thing that being a production engineer, I've struggled the most with as working in an AI company. AI engineers have a comfort level with uncertainty that I do not. I like deterministic systems. This happens, that happens, right? AI is not that way at all, and I still have it's like talking to a foreign person. Like, no, it's supposed to do this. If you've ever tried to do a demo with AI and try to have it repeat the same thing, never does. It's always a slightly different thing. You're like, stop doing it that way. So there's a bias for perfection, I think, in this world, because that's just what we've been trained on, right? We think about things like 4 nines, and we want our systems to be reliable. And so if you get an unreliable response from AI, you're like, that's not good enough for me. So there's some of that, I think. There's also it might write software differently than I do, but so does the coworker that sits next to me. We have different stylistic choices. We have different preferences. But I think when we have AI write our code for us, and then we're the ones that are going to be committing it, we're like, well, it has to be written in my style. Is that necessarily true? It might just be different, not necessarily better or worse. And we reward code, not solutions. GitHub's contribution graph is a great example. It's green because you made contributions, you made commits, right? That's rewarding people producing code. That's possibly the wrong incentive in the future. So what is AI coding like today? Like, if this is inevitable, a couple years ago, it was kind of just a pile of bricks. It sort of worked. It wasn't until Claude 3.5 came out. That was about a year ago. It was June of last year that Claude 3.5 came out, and that really exploded what was possible. That's when Cursor took off. That's when Augment really saw performance gains. That's when it could actually write code that was actually pretty good. And now that Claude 4 is out, it can write code that's very good. In the last 2 weeks, basically every AI company has launched some version of agents, particularly remote agents, where I have this autonomous system that's not even in my IDE anymore that can then generate code for me. So that's where we're at. That's how quickly this world moves. We went from it kind of works to I'm happy to give it some tasks and let it go to town in less than a year. So then how do we write, if this is inevitable, how do we build systems so that AI can help us write that code? What do we need? So we need to have documented standards and practices. No code base is consistent that I have ever worked on, right? A third of it is like 5 years ago ideas. A third of it is like, this kind of works. And a third of it's like, here's what was on Hacker News this week. And so we decided to put it into production. And so what would the AI decide to build? Should it build 5 years ago solutions, or should it be last week's solution? So you have to tell it, do X, not Y, is a really important thing. Have simple and reproducible environments, right? Like, one of the most powerful things of AI over the last 6 months is that AI can use tools, meaning it can run your tests, it can use your terminal. But if your environment is not reproducible in a very fast way, such that the AI can also use it, then how would you expect it to run those tools? That's one of the best ways I find to find errors in my code is I actually run the code. I run the tests, I run the linters, etc. Testing infrastructure, linting infrastructure, static analysis, build tools, make sure the AI has access to those things, and they're reproducible. I think that's how we validate our code. Establish clear boundaries. I wouldn't give an AI a task of like, extract this module with a strangler pattern. What am I expecting it to do? Like, I wouldn't give any engineer that work, right? I would need to say, it needs to do X, Y, and Z. This is the approach I want to take, So we need to set those out. And then clearly define the tasks and the work that needs to be done. I'm not talking about like elaborate PRDs that give you the entire technical architecture and every feature list that you need, but you need to be very clear about the task and the work that needs to be done. Now, if you're thinking to yourself, this just sounds like engineering. Like, this is just what we should have in our software. Well, that's 100% right. I think we've like accidentally forgotten that text generation doesn't know how to build software. It just knows how to generate text. So how can we force it into like the same systems we use to build software? It can just do it a little bit faster, a lot of it faster. But just do good engineering, and AI will help you do good engineering. The other thing that I think is important is code review will become the most important skill any engineer is going to have. It probably, as I say, should have been number one to begin with. Reviewing code is not a skill we do a great job of training, not a great job of like interviewing for. Anyone have like a code review question on your like interview panels rather than like, I don't know, whatever technical gotcha you're trying to trick people with? Like, give them a PR that's got problems and have them like give comments on it. That's the future, right? Unfortunately, code review hasn't really changed in 30 years. Like, we're looking at diffs still. So I think there's going to be an explosion of how code review is going to change. Like, looking at a lexicographically listed set of files. Like, oh, file A changed. Okay, let me read what changed in file A. Great, that sounds great. Okay, file B, that's the next and most important file. That doesn't make any sense to anyone. That's not how code should be evaluated. So we're going to see an explosion in this space, I think. Hint, hint. So if you feel like you are that, like, I have no idea what I'm doing dog, because I feel like that all the time, when it comes to AI, I've got some tips here. I want to highlight a few of them that I think are really, really important. One, AI talks like a human, but is actually a machine. The best example, I was yelling at AI one time, and it's like, oh, I'm sorry, I skimmed that file. I didn't read it thoroughly. What does that mean? Machines don't skim things and read them thoroughly. It's because it's text generation. It knows that on all of the books that have ever been written, and all the code that's ever been written, and all the emails it's scanned, it's like, oh, when I'm being yelled at, I apologize first, and it's literally just pattern matching words. So like, we can anthropomorphize these things very easily, and don't be confused that it's not actually doing what it says it's doing, because it's generating text. I actually think we're going to see a lot less interfaces with chat, because like, I don't need to see volumes of text being spat at me as it's outputting code. I think we're going to see a lot of that go away over the next couple of years because it's not valuable, and it also misleads us. Another one is explore directions. This is a great way. Spin up multiple agents. Spin up an agent with a slight variation on the same problem and see which solution you like better. See which ideas were better within those things. I do that all of the time. Don't forget that different is just different. It's not better. It's not worse. It might not have been how you have solved it. Does it do the job it's supposed to do? Does it make the trade-offs you would make, but has written it differently? Don't get too caught up in the differentness of it, and make sure you're focused on, is it solving the problem I'm really trying to solve? And the last most important one that I use all the time is this define, create, refine loop. So I think Lachlan also mentioned it. Create a markdown document. Have it, I usually start with a chat when I'm like, hey, here's what I'm trying to solve. Chat, chat, chat. Output a markdown document with all the details of this chat. Throw it into that, in there. I make some more edits. I do some refinement in there. And then I tell the AI, use this file as your reference. I start a whole new one because I don't want any of the context that existed in my last chat to be like, oh, well, here's some ideas we thought about. No. Throw those away. We want just this and start building this thing. And do that loop over and over and over again. Start with get a plan built, define it, have it create the thing, and then refine it. One place I would disagree, don't try to one-shot things. Until you get very good at it and it's well scoped, one-shotting is here's one prompt, it solved the problem, great, ship it and repeat. That's a very hard thing. Mostly for AI, doesn't always do a good job of it. I don't do a good job of prompting the AI in the way I'm supposed to prompt it. So don't try to one-shot things. Iterate on it over and over and over again. There's nothing wrong with that. So before we get to Q&A, I do want to leave with you a few questions for if we want to talk about work while drinking and having snacks, is what's going to be different in our engineering organizations now that AI is going to be writing a lot of code, right? Ask each other, what do you think? What are my hiring requirements now? What's my interview process look like? I'm not just talking about do they use AI to cheat on the code part, but should you be doing a code review rather than a technical interview of some other kind? How are you enabling your existing team? There's a lot of fear about this, and I think in our industry, in professional science. Are you encouraging your team? Go ahead and use it. You're not a bad engineer for using it. I think I'm a pretty good engineer, and I commit code with AI every single day. I don't think I'm lesser for it. I just get to ship more stuff. And then lastly, what does your organization look like? Is the 2-pizza team really the right size of an organization? A team with 8 people with a product manager, 6 engineers, or is 4 better? Do you get less coordination cost because you have less people to coordinate with, but you can get just as much work done, and then you can split those teams up. So think about what are those changes that your organization is going to need in order to support this, because this is, in fact, a huge shift in the way we're going to be writing code, and we can't just be like, well, everything in the engineering organization is staying exactly the same, everything's going to work out. It's not. So please consider all of these things. I don't have solutions. We're still very young in this space, but talk amongst each other and chat with me. I'll be there in a few minutes. And happy coding, and I will see you here next year. I probably could take 2 questions until I get hooked off the stage. Fire away.
So you make a point about AI not being simple for architectural decisions. I was curious to just hear more about that. Do you feel like that's fundamentally where the technology is today, or was it more a comment on the fact that it's hard to get the right context into one place for it to be able to make decisions?
So it's not, I don't think it's necessarily about context, because again, I think it's all about trade-offs. And then it's also about pattern matching. So every architecture starts great, monolith is a very broad concept, right? But as my monolith is going to look different than yours. And at some point in time, at some scale, the number of times AI has seen that version of things starts to diminish. So depending on the task, refactor my monolith into a microservice. This is a crap way to use AI, but like extract this module, I think we'll get there. So it just depends on that scale. So I think that's why architectural choices are much more complex, because they go beyond just what code do I write, but like what performance characteristics of Postgres do I have versus Kafka versus Bigtable or something, right? Like all of those choices are not, I'm adopting a bunch of debt every time I make one of those technical choices that the AI doesn't care about and doesn't really know. It can help me write the SQL queries, it can help me write the adapters to various systems, but it can't make those choices for me. And maybe we'll get there, but I call those Tahiti problems. Like if that's where we're at as an industry, we're all gonna be in Tahiti and AI can just go solve that problem. Take one more. Can you shout just a little bit?
In a legacy code base, engineers generally report that quality suggestions are worse or like not that useful. Do you have any kind of tips for how to make stuff work in a legacy code base?
Yeah, so tip number one is use augment rather than those other things. I know that's like tongue in cheek, but we actually, like our differentiator is around our context engine, that we actually index your entire code base. And so we have an understanding of it that doesn't exist in something like Copilot or Cursor that doesn't have that kind of indexing. And it's not RAG, it's custom. So one, use augment, but that's fundamentally the problem is like in legacy code bases, the AI is trying to put out code that it knows today. And most legacy code, there's not a lot of GitHub repositories that probably look like a 10-year-old piece of code, and it's trained on much more modern practices, so it struggles in that way. But if you can get it the match, if you know how to if you can document those things, like use AI to do the research into your code base of like, read this module, here's like 10 files, do an abstraction of what that looks like, and keep those documents around, that can help the AI of like, here's our architecture files, or here's our patterns directory. Have the AI reference that is probably my best offer. So, cool. I'm gonna let you all get snacks. I'll be next door chatting as well. So thank you so much.